beyond the language. So this is my talk about Ruby beyond the language. So today we are going to have in the Ruby virtual machine in Toronto. I'm going to prove that register machine is faster than stack machine for example. 冗談です。そう、何もわかりません。これはテクニカルカンファレンスで聞いてたんで用意したんですが、今日は成果発表会なので別の話をしたいと思います。Right? So, first of all, I am honored to be the first person to welcome you to oedo04. Thanks to Akira-san and everyone involved. And I am very honored to be here to speak in front of you. But I was not wrong. ごめんなさい。これはすごく簡単なことではありませんでした。人の前で話をするのはすごいビッグディールだと思うので、でもセカンドチャンスは来ないと思ういや来ないかもしれないと思ったのでやってみようと思いました。So here I am. じゃあよろしくお願いします。Hi, my name is Ebi. Most people know me as Aaron's partner in crime, and I am also Aaron's sensei for creating whatever Aaron needs for his talk. So this is my code dojo at Local Park. So I told them don't tell everyone before they perform, but don't tell anyone. So I did a film directing for Aaron's talk. And then恥ずかしいですね。すごい恥ずかしかったんです。それとダンスもしました。そうこれは AR のために私たちがみんなでサポートをするために踊ってみました。でこれはpicture of me in the Rails Conf 2010 and ここにいますね。で、私はフォトグラフィーもします。これは2013年のホリデーカードに作りましたとあとステッカーの制作もしました。で、私はうちのね、このゴルバチョフの手紙が出てきますね。Twitter はもうすでに10,000 フォロワーがもう出てる。と、これはもう一人のあんまり有名じゃないね、シータですね。仲がいいです。で、This is my first talk ever, just in case if you did not know this. And I was born in Japan and live in United States. So I'm not a programmer, if you did not know, just in case. でもちょっとは知ってます。これは学校で勉強しました。デベロッパーじゃないから帰らないでください。No refund, right? かずめさん。遅いですね。あ、でもベーシックは知ってます。I took the basic programming at school before my graduation, and then staff member realized that I was supposed to take introduction to computers, not introduction to programming in basic. So they removed the course requirement for future students. So I did the basic at my school. で、今日は皆さんと3つの話をしたいと思います。Conference, community と Keeping Ruby Alive. So it all started in 2008 when Aaron Patterson asked me to join his band going to RubyConf. Then let's start the journey there. I was a known programmer in 2008 when Aaron asked me to attend RubyConf 2008. Guess what? In 2014, I'm still not a programmer. はい、どうしてかわかりませんね。But I have become one of the biggest supporters of Ruby instead. I have been to lots of conferences since 2008 to present. My first conference was RubyConf 2008, middle of nowhere in Florida. あ、でもワニはいました。ワニが庭に2匹いたんですよね。ね、ダジャレの先生。で、そう、このカンファレンスに行く前にアーロンが聞いたんですね、私に。もしプログラマーのフェスティバルが RubyConf というフェスティバルがあるから行かないかって楽しそうかなと思ったので行くことにしました。Then that was the beginning of my journey with Ruby. それ以来、50以上のカンファレンスに10カ国以上の国に連れて行ってもらいました。As a non-programmer, I have been to more conferences than anyone I know. Today I would like to share my idea and concern from my standpoint as a non-programmer towards Ruby. So, どうしてRuby カンファレンスに行かなきゃいけないんだろう。なんでみんなカンファレンスに行かなきゃいけないんだろうと思ったんですね。When Aaron asked me. で、Why do you need to go? Now I understand why. 理由は人それぞれ違うと思いますが、I would like to ごめんなさい、すいませんね、スイッチしちゃって。I would like to share my point why you should go to the conference based on my experience. You see many people online, on Twitter, RC, and other things, but you may not know how they are in person, what they look like. Or maybe you can't tell their personality. When you meet people, you connect them through conversation. And when you do it at conference, you already have something in common with them, which is Ruby. So you can talk about that. オンラインで喧嘩したことはありますか？あるんだったら生きているうちに外国のカンファレンスに一度は行ってみてください。ギブアップする前に一度は トライして会いに行ってみてください。He or she cannot be as mean as they are online when you meet them in person. 話は絶対聞いてくれると思います。で、here's your chance to prove yourself. Discuss with them about your point. Tell them they are wrong and you are right. 直接言う機会があると思います。プルリクエストを無視されたことはありますか？返事がなかったこともたくさんある人がいると思います。This is your chance to get attention from them. Right, Aaron? At the conference, you can get inspired from other Ruby fellows from their talks through RubyConf. For example, my friend Aaron Quinn shared his love of making bacon. He didn't just tell everyone that he loves baking. He taught the audience how to make bacon from scratch. Sometimes programming conferences aren't just about programming. Travel. If you are interested in foreign RubyConf and traveling to foreign countries, it is a good idea to combine both together. Give yourself an excuse, get out of comfort zone から出てきてください。Meet people in real life if you have met them online and work together in person. すいません、写真が入らなかったんですが、ここで RubyConf ユーグレイでナリさんや豊さん、江藤さんに会いました。それで、ワールドカップサッカーゲームに行きました。Right? これは、メキシコのマグマコンです。これはカンファレンスの外ですが、オーシャンで泳いだりしました。みんなで一緒にメキシカンフードを作りました。それだけじゃありませんが、それは一部です。昨年は先ほど話をしたウィンストンのオーガナイズするレッドRubyConfシンガポールでたくさんの食べ物を食べました。シンガポールはいいところだと思います。ぜひ行ってください。で、食べ物、of course, you can enjoy local food on your free time as well. There are all things that you can do, but when you go to conference outside of Japan, you will see things differently. You'll gain new experiences. You'll think differently. After I attended many conferences, I started seeing the festival of programmers, something different. Something bigger than just a magical gathering. I saw them as a community, a universal scale, crossing cultural boundaries, where people discuss what they care about in Ruby online, offline, and at conferences, and after conferences. ごめんなさい、これは Raspberry です。言うのを忘れました。すみません。皆さんという言葉を聞いたことがありますか？これは Matsu is nice, so we are nice のショートヘンドの言葉です。Google してみてください。でも私はこの言葉を聞いたときにマッチだなって思ったんですね。Then I started wondering every time Aaron told me about how to improve things about Ruby, not just code. It's about the people how he can tell them to listen to his point without getting into dramas or fight. Vice versa. I thought, I cannot send patches or bug reports, but I can listen to him as he needs. I can spend my time to come along with him to the conference as he wants. That's how I can support Ruby, I thought. So here's a story. I saved his life at the conference once. これは、これが言いたかったのは、私がアーロンの人生を作ったことがあることを話したいと思います。カンファレンスで2時間前にアーロンが自分のパンツを持ってきてないことに気がついてでも私がその時にいたのでパンツを買いに行って彼のトークをセーブしたというなのでお友達を連れて行ったり自分のパートナーを連れてカンファレンスに行くことにも意味がある時もありますで、I was able to meet so many great people like 角谷さん、ヤフダたくさんいますか、チャードとか、ルビジャンで有名なエリック・デイビスですねのこれはエリック・ホーローと、ライアン・デイビスを合わせた顔で本当はこんな顔ではないから気をつけてくださいあとお友達のアレキサンのジョゼ・バレンですねとかあとジムですねAnd things in common was to all the people they have in common is to keep Ruby alive. So I'd like to share a story of Aaron Patterson, why he tried to keep Ruby alive. He keeps Ruby alive because he does not want to switch language to bad language at all. He was forced to switch languages for a job, and it was a bad experience for him for a long, long time. Then he became a sad programmer before he met Ruby. So he started looking for a job position in Ruby. However, there were not very many at that time in 2005. So he found a job in 2006 at an online advertisement company on top of a 30% pay cut. And compared to that time, now you can find it more easily. So he wants to make sure that everyone can find a job position with Ruby everywhere so that we can all have a happy programming life. But he's not unemployed, rich guy or CTO at startups. He's a salaryman. AT&T のサラリーマンですね。But he was able to convince his boss to work on the open source so that he can be officially as a間違えましたそうでなんでアーロンがフルタイムの Rails コントリビューターなのかというのは so that Rails stay alive and gives jobs to developers with a wide range of skills in Ruby. If it is not true, please come talk to me or Aaron during break. Not now, please. At last, I would like to share my story about Jim White, who passed away this year. One of the Ruby のファンの人ですね。でもあります。Smart, kind, and funny person. I met many people through Aaron's, and their kindness and passion towards Ruby influenced me into having a different perspective that I have never explored before. I noticed Ruby is not just a programming language, but something that brings people together for building something greater. When I met Jim, who passed away this year, he welcomed me with open arms, accepted me as a friend in the community, regardless of my occupations as non-programmers. His kindness also helped me to understand the idea of a Ruby community as an open source, as open community to others as well. His kindness makes me want to treat people in the same way as how Jim made me feel comfortable in Ruby community. Kindness is contagious. I believe this. But I also know that being mean is contagious too. So we need to focus on being kind. I miss him. We all miss him. Not because he was the author of Break, not because he was my friend, but because he was just about the nicest person I ever met. No question. I will miss him. We all miss him. Thank you for your time and kindness. And now it's time for the bonus round. Earn Patterson talk, adequate record. For those of you who would not be able to attend for upcoming Rails Conf in Chicago next week. どうもありがとうございました。
じゃあ質問がある人はこの後今週がまだちょっと枠もございますのでぜひ参加していただいて今はいいですか今質問を受けていただいて
後です。
後ですかはいじゃあ
後でビールを飲んだ後に来てください。ありがとうございます。
この後もいらっしゃいますので、ぜひですね、エミちゃんにも声をかけてもらったりするといいなと思います。あとはどうぞ。はい、これお願いします。はい。
Okay. こんにちは。Rails を使ってる人はいますか？います。よかった。私はヒゲの山男と申します。最近、丸 HH さんは Rails はお任せと言いました。でも、Rails の実行速度といえば、お待たせ Rails とにかく、これから英語で話します。実は日本語で練習の時間はあまりなかったかな。ごめんなさい。Anyway, I have to really hurry through this because how much time do I have? 30分 ?30分だっけ ?30分。Okay, so I have like 100 slides and I should probably get through them. So, adequate record とは、adequate record is a fork of active record with performance improvements on it. So it's just a straight fork of active record. And I gathered a bunch of quotes from people, like what people are saying about adequate record. And I want to share them with you today. So people who are using it in production, it's like active record, but more adequate. It's from me. I said that. It's all right. I've seen better, but this is fine. It seems to work from you to And 何それ? So why did I name it adequate? I mean, adequate is like, it's not a very good name. But the reason I named it adequate is mainly from humility. Like, I think as a developer community, we need to be more humble. I'm really tired of projects that are named like Turbo something and Active that and like I'm so amazing. It makes me feel really terrible. Like I just want people to look at my project and be like, okay, that's good. It's good enough for the job that I need to do. It's adequate. It's fine. So for me, it's mostly like an anti-marketing term. Like I don't like people marketing at me. So that's, I want people to enjoy the software for what it is, not the marketing terms behind it. So why a fork? Like, this is really just a fork of Active Record. But why did I just fork it and add this stuff on it? And the reason is because I don't actually want new features. I think today Rails does maybe 80 or 90% of the stuff that we need to do. So I don't understand why, like, every time we release a new version of Rails, we just have to add another line to the gem file. It's like, okay, well, we have a new release of Rails, let's just add something to the gem file. Okay, everybody, here you go. That's great. What I really wanted is I wanted something substantial, like performance improvements. I mean, make what we have better, right? Anyway, so I want to talk a little bit about adequate history. This is the history of this idea, and unfortunately, this particular project has taken me 3 years. Seriously, I've been working on this stupid thing for 3 years. I've had the idea in my head for a very long time, and I spoke about this idea at conferences over and over again, but now I've finally been able to realize my goal. So I want to talk about how Adequate Record actually works, or how Active Record works, and then I'll talk about how Adequate Record works and the performance improvements on Active Record. So how Active Record works. Basically, the way it works is when you write some code like post.find 10, it gets converted into these Active Record relation objects. So that's the first step. It goes through a transformation into Active Record relation objects. Then it goes through a second transformation step, which converts those relation objects into nodes, into basically a SQL AST. Then we compile that AST into a string and send that to the database. And then the database returns data, and we turn that into Active Record objects and then give it to you. So part one of the adequate change, and this happened, I did this change maybe 2 years ago, I think, is you'll start to notice, like, okay, well, when I used to do post.find1, you'd see, okay, I did the select, and it would put the ID in there. And the interesting thing about this is if you look at these SQL statements, the only thing that changes in it are these numbers here. That's the only thing that changes. So when you add an ID, only the ID changes. So it's interesting because that's the only dynamic part of the query. The rest of the query is static. And you'll have noticed, like, over time, if you look at your Rails logs, you may notice seeing something like this, where it changed to, okay, now it says select star from post where ID equals question mark. And this is where we start to introduce prepared statements and bind parameters to Active Record. And the reason we did this is because we wanted to separate static and dynamic content. So the reason we wanted to separate static and dynamic content is basically because of the adequate theory. The theory that's good enough. Hopefully good enough. So remember this graph here of all the things that we had, all these transformations that are going on. Now this first part of the computation that generates the SQL statement, if it's always generating exactly the same SQL statement every time we run, then we should be able to cache it. So if the computation is always the same, we should be able to cache that entire part of the query. So that was the first part of Adequate Record. Part two, now that we've separated these particular things, we've separated this data from the queries, but that doesn't mean that we can treat them as two different things. So if you look through Active Record's code, you'd find that, well, yes, bind parameters are separated from the SQL statement, but the actual Ruby code is very tightly coupled together. And this came from the fact of the association code in Active Record. The bind parameters are tightly coupled with the association code. And in fact, if you go look, I went and looked at the source code to try and fix this, and I found this method. This isn't the whole method. That's the whole method. And that's just one method. It's one. And I like to call this the one method to rule them all and in legacy code bind them. So anyway, what this method does is it constructs a bunch of relation objects in order to construct that SQL statement. But that code was too hard. It was just too hard. I couldn't understand, I couldn't rip the two apart. So what I decided to do is refactor things, and the next step was to remove has and belongs to many. So if you use Rails 4.1 today, has and belongs to many doesn't exist anymore. It's not in Rails. But that's not 100% true, and I'll kind of explain why that is. If you think about has and belongs to many, and you think about has many through, they're basically the same thing, right? Has and belongs to many has three tables, but you don't have a middle record, a middle model between the two. So what I did is I changed has and belongs to many so that it generates a central model that's anonymous. You don't know about it. So you can still say has and belongs to many, and everything is supposed to work exactly the same way as it did before. It's just that under the hood, we treat it as a has many through. And what that allowed me to do is delete a bunch of code. So after all that bad code, let's look at this. So this is my favorite diff. Like, look at the red. There's red, 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 and no green. I love that. No green. I feel like I'm eating all of the code in there. It's delicious. I love chewing up that code. All right, so that's adequate record part. The changes part 2 and part 3. Part 3 is that now we have those things separated. We have relation generation and bind parameter generation separated completely. That means that now we can introduce a cache. I'm going to show you what the cache looks like. This is what the statement cache looks like. So you create a new object, and inside that block you can say, okay, create an active record relation. And this can be anything you want to, like stuff you would normally use in your Rails application. And then you can execute it over and over again. And it caches everything, all the SQL statements that were generated inside there. It only calls this block once, ever. So I kind of want to look at the internals from this because we're going to look at the performance, and looking at the cache internals is a little important to that. This is what the cache looks like. It holds on to the bind parameters that you declared, and it also holds on to the compiled SQL statement. So you'll see it just holds on to bind parameters, and it holds on to the SQL string. So I changed the internals of Active Record to wherever we use relation objects inside of Active Record, I changed it such that we just cached those compiled values. Since we know that nothing in there is dynamic anymore, we can just do it once and cache it. Now you think, okay, that's great, Aaron, but what uses relations? And if you go through the Active Record internals, these are all the things that use relations. So anytime you call find, anytime you call find by, all of these has many through, has belongs to many, all of these things use relation objects, which means that we're able to add a cache to all of these and improve the performance. So this is, for example, this is what the cache looks like for find by ID. Basically, you'll see in here that we actually just generate a relation object right there. You might actually write this code in your application or something that looks similar to this, but these are actually Active Record internals. Then we don't have anything dynamic in there. The only thing dynamic is this ID that's passed in. So every time you pass in the ID, this is where we pass in dynamic data. So as I was doing these refactorings, I want to talk about a little bit of some fun facts. Fun facts are, these are the different ways that you can call post.find. You can call it with a number, you can call it with an array, you can call it with an array of arrays, you can call it with an array of hashes, or a hash, or another Active Record object, or all of those plus a block, or all of those plus scoping. And I have no idea what any of them do, but I can tell you we can't cache them. It doesn't work. The only one that we can actually cache is that first one, find by ID, but I think that's the one that most people use. So I want to talk a little bit about measuring performance, different tools that I was using for measuring the performance of adequate record. And the first one is benchmark IPS. Now, what this tool is for is to measure the number of iterations per second that you can call a particular bit of code with. And I want to compare this to using the normal benchmark library from Ruby's standard library. This is what the normal benchmark library looks like. So you want to benchmark something, you say, okay, n.times, call that thing. But the problem with this benchmark is you don't know, like, well, how big should n be? Like, what is that value? And if you set n too small, like, your output will look something like this. Oh, it's just a bunch of zeros. So you have to say, okay, well, I'll increase n, or I'll decrease n, and you have to keep adjusting these particular things. But what benchmark IPS does is it says, okay, how many times can I call this code in 5 seconds? So it just sees how many times can I call this code in 5 seconds, and you get number of iterations per second. So you know your test is always going to take 5 seconds, and you can compare the rate at which you call those things. The other cool thing that it gives is it gives us a standard deviation. So you see that plus or minus 3% there is a standard deviation on the call. And standard deviation is very important because if your performance improvements aren't good enough, they might be within a standard deviation. So you can't tell whether or not you actually made performance improvements. You need to be outside of that plus or minus 3%. So you can, the standard deviation lets you separate noise from your benchmark. The other things I used are GC stat. And I have to say, like, Koichi actually just made a bunch of improvements to his garbage collection stats gem, so I need to update these slides because they're better than this. But what I use is GC stat, and I say, okay, I want to know, here I can count the total number of objects that have been allocated in the system. So I have a block of code, and I need to understand how many objects does this block of code allocate. So I say, okay, this is my actual benchmark. First I warm up the thing, I'm like, okay, let's find once. Then we count the number of objects that have been allocated, run our benchmark, and then count the number that have been allocated in the system again, and say, okay, subtract those two and divide by n, and now we know the number of objects per call. So with that in mind, what I want to do next is I want to look at the performance of adequate record. Like, what are the actual statistics compared to previous versions? And hopefully Shibata-san will be happy with these. So the first two is find by ID and find by name, and I want to compare these two because they're essentially the same thing. We're saying find a record by name or by ID. The SQL statement is essentially the same thing. And this is our statistics over time. So at the bottom is, or along the x-axis is basically time. So we start with 2-3 stable, and then we go all the way up to today. And the y-axis is the number of calls per second. So the higher it is, the better it is. So you can see there kind of in the middle, 2-3 stable was actually, I think, was our fastest. And time went down, like it went down over time. But you can see adequate record there jumps up. That is, hopefully that's adequate. People find this to be adequate. So these are the calls per second with MySQL 2. And you can see again, like 3.0 stable, we moved down, but we're coming back up with 4.1 master, and then of course adequate record jumps up. This one I think is interesting. So this one, MySQL 2, this is the database adapter, and it wasn't available in Rails 2.3, so we don't have any numbers for that. But if you look at MySQL at 2.3 stable, like it's actually very fast. And then it went way down. So you can see these numbers. It starts out very fast with MySQL, goes down, but then we come back up here with adequate record. Same idea here with PostgreSQL. You can see these graphs look mostly the same, and this is like the percent faster than 4.1 stable. So you can see we're over 100% faster, like over double the speed with SQLite 3, and we're much faster on all of these. Percent faster than 2.3 stable. So we're still, adequate record is still even faster than 2.3 stable, though not much. Another statistic I think is very interesting is the objects allocated per call. So if we look at the number of objects allocated per call, we reduce them greatly on adequate record. It's the same idea across here. So lower is better. We want fewer objects per call. And this is with all of the databases. What I think is interesting is if we look at find by name, so look at these two on the very left here with 2-3 stable, that yellow line is MySQL 2. So you can see, MySQL. You can see in the early days of Rails, it was very, very biased towards MySQL. All of these other ones are PostgreSQL, they're much slower. And I think it's just because people didn't pay attention to those other databases in the early days of Rails. You can see the same thing here, exactly the same sort of trend in this one. And as the object allocations go up, our speed went down. So with adequate record, we have 70% fewer objects per call than 4.1 stable, 55% fewer objects per call than 2.3 stable. And the next thing I want to look at is I want to look at association code. We talked about caching those things. So we'll look at has many and has many throughs. Association calls per second, so we measure how many times can we call a particular association in a second. So if we have, say, like, person has many magic cards, how many times can we call magic cards? And we see, again, we're increasing the speed with adequate record. The blue line is has many, the green line is has many through. MySQL, you can see again here, 2-3 stable is very fast. Increased or decreased as time went on, and now we're back up to the top there. Another same trend across the board. PostgreSQL, same trend. Percent faster than 2-3 stable. It is much faster than 2-3 stable and 4.1 stable. So I want to talk a little bit about adequate challenges. So doing all this work, we can't get these performance improvements for free. So nothing comes for free, unfortunately. We had to trade memory for speed. So this is just a cache of SQL statements. It does trade memory for speed, but we can understand the memory that it uses, which is why I looked at that cache object earlier. The total cache size you can measure by saying, okay, what are the number of ways that I can call find by? So find by star, count that, and then multiply that by the size of the cache. And the cache isn't actually very big, though I haven't measured the size, so I can't tell you exactly. But you can measure the cache size. And if you have a finite number of find by blah in your code, then you'll know that the cache size should be equal to that. The other thing is raw relations. Like, everybody might ask me, like, okay, so why don't you just speed up the code that we use today? Like, for example, in my controller, I write person.where name, name.2a. Why don't you just make that faster? And the answer is I can. We can cache that, so we can make that faster. And I have an experimental branch where we do make that faster, and you look here, this is another branch. We say, okay, iterations per second on that particular code, querying by name. With the experimental branch, we can get a bit faster. The only problem is we have to calculate cache keys. Like, how do we key that cache? And here's what the code looks like on that branch. You can see that maybe 80% of the code is key calculation, and then maybe 20% of the code is actually figuring out what the query is, or actually executing the query. And unfortunately, we have over 11 variables that impact the cache key. And that previous code that I showed you, it only handles 2 types of caches. It only handles 2 types of queries. So there's a possibility of 11, I have no idea, many combinations, and this only handles 2. So I want to do one more experiment with you. We have two examples here. The first example is something you might say in your controller, like person.where name Aaron first, and person.findById Aaron. So these are essentially exactly the same queries, but if we do a benchmark comparison, and this is on the experimental branch where we cache both of these, if you compare those two, doing find by name is much faster. It's actually 3 times faster. And the reason it's 3 times faster is that when you say person.where.where.where.first, we still have to allocate all of those relation objects for you and then calculate the cache key. So we have object allocations plus cache key calculation time on top of that, compared to doing just the find by name where we can cache everything. So I have to ask the question, should we cache all relations? Should we make it all faster? And I think the answer is no. I don't think we should. The reason is because calculating this cache key is too hard. It's error prone. The other problem is it can cause memory bloat. Like, I don't know the different ways that you might call, person.where.includes, etc., etc. And you might call them in many very different ways, and it'll actually bloat the memory size of your application, even though maybe you don't use those things very often. I think that it would be better if we forced people to actually specify a key for this cache. I want a new API, something that looks like this, where we say, okay, I want to declare a cache query, and we say this is actually the cache key. So that's our cache key, and all this thing does is it builds up our relation, and this relation is cached. This block is only ever called once, and then you're allowed to call it multiple times. And this will be just as fast as if you had said, okay, find by name. And you can make any of your queries just as fast as that. So I think I'm a little bit early with this, but maybe we have questions, hopefully. I think I should probably clarify. So I said adequate record is actually a fork of active record, which is true. It is a fork of active record, but I plan on merging that back into Rails for Rails 4.2. So, ちょっとつまらない冗談だと思うけど Anyway, it will be in Rails 4.2, and I think Rails 4.2 will be the fastest Rails ever. I think we can make it the fastest Rails ever. So I'm very sorry that it is slow in the meantime, but thank you very much. If you have any questions for me, I guess it's okay. 日本語でもいいと思うけど、多分ビールの後ではもっといい。
The cache query API looks a lot like the name scope syntax.
It does.
Are you gonna put them together or something?
So no, we're not going to put them together. Well, maybe. The problem is that with scopes, people expect the block to be executed every single time. And many people will put in that scope block, they'll say like, okay, I need all the records that are newer than today. And it'll say like date.today. And if we only call that block once, then date.today will be only once. So we can't combine those.
I see. Makes sense.
You said you wanted to merge this back into Trunk. Have you gotten any feedback from other core members of Rails on what they think of adequate record?
Adequate record? Oh yeah, absolutely. We talk about it. We talk about it frequently. I basically use it to troll DHH. I'm serious.
And their feedback is all positive? Are there any objections or maybe like other kinds of feedback?
No. We've all been reviewing the patches together. I mean, basically the plan is to merge it into master at RailsConf. Nobody has any objections to it. I think Basecamp is running with it now. It seems fine. It seems adequate.
Any opinion from John?
Nani?
John.
John はいますか to you?
So, did you get any opinion from John Layton?
No.
Yeah?
No. I haven't. John hasn't really been around much lately, or he hasn't been. I know he's really busy with his startup, so he hasn't been in the core room lately. But Ken-chan wa yorokobu.
はい、じゃあ。
はい、ありがとうございます。